Hello, everyone. Welcome to today's session. I'm excited to introduce our topic, comparing quantities. In this presentation, we'll explore different ways to compare amounts and understand their significance. We'll look at some key concepts and practical examples that will help you grasp the idea of comparing quantities effectively. Let's get started. Let's take a quick look at the contents of today's session. We'll start with ratios, which are fundamental in comparing quantities. Then, we'll explore equivalent ratios, helping us understand how ratios can be scaled up or down while maintaining their value. Moving on, the concept of proportion is closely related and essential for solving many problems. We'll also cover the unitary method, a powerful tool for solving problems quickly by finding the value of a single unit. Next, we'll delve into percentages, starting with what they are and how to convert fractions to percentages, which is a common task. We'll see how percentages can be used even when the total isn't out of 100, which broadens our understanding. The slide also highlights that parts always add up to give a whole. This is key when working with ratios and percentages. Then, we'll discuss how to find percentages when the total isn't 100, and how to convert percentages back into how many parts, which is very useful in real-life scenarios. Further, we'll look at increasing or decreasing values as a percentage, a crucial concept in calculations involving growth or reduction. We'll also examine how to find the selling price if the cost price and profit or loss percentage are known, along with how to determine the cost price from selling price and profit or loss percentage. We will touch on the use of percentages in various contexts, such as in financial calculations, and how to handle decimals by converting them to percentages. Finally, we'll explore simple interest, including how to calculate it over different periods, like 3 years, and understanding profit or loss percentages. All these topics are interconnected, forming a comprehensive toolkit for solving problems efficiently. So, let's get started and see how these concepts come together in practice. Let's take a closer look at ratios. A ratio is essentially a way to compare two quantities. Now, an important point here is that these quantities must have the same units. Otherwise, the comparison wouldn't make sense. When we write a ratio, we use the symbol, which we read as 2. For example, if we have 3 apples and 5 oranges, we could say the ratio of apples to oranges is 3 to 5. Another way to think about ratios is by expressing them as fractions. So, the same ratio could be written as 3:5. This fractional form is useful for calculations and for understanding the relationship between the quantities. Connecting this to our broader theme, understanding ratios helps us see how different quantities relate to each other, which is fundamental in analyzing data, making comparisons, and understanding proportions in various real-world scenarios. Now, let's talk about equivalent ratios. You can think of equivalent ratios as being similar to equivalent fractions. The key idea here is that to find an equivalent ratio, we need to express it in the form of a fraction. Once we have that fraction, the process to find an equivalent ratio involves multiplying or dividing both the numerator and the denominator by the same number. This ensures that the ratio remains the same, just expressed differently. This concept is really important because it helps us understand how ratios can be scaled up or down while maintaining their value. It ties into the larger idea of understanding proportional relationships, which is at the heart of this whole presentation. Let's talk about proportion. Proportion is all about showing the relationship between two ratios. It helps us understand if two quantities are in a fair and balanced relationship. When we say two ratios are in proportion, it means they are equal. And that equality is what allows us to compare different sets of numbers or measurements effectively. Recognizing when ratios are in proportion is essential because it helps us solve problems involving scale, size, or comparison. Throughout this presentation, understanding proportions will be key to grasping how different quantities relate to each other in real-world situations. Let's talk about the unitary method. This is a really useful approach because it simplifies complex problems. Essentially, what you do is find the value of a single unit first. Once you know the value of one unit, you can easily determine the value of any number of units you need. For example, if you know the cost of 5 apples, you can find the cost of just one apple and then multiply to find the total for any other number. This method is powerful because it helps you break down problems into manageable parts, making calculations quicker and more straightforward. It's a key concept that ties into the overall theme of solving mathematical problems efficiently and accurately. Now, let's talk about the concept of percentage. The percentage is another way of making comparisons, and it's really useful because it helps us understand proportions easily. When we use ratios, we often need to make the denominators the same before we can compare them directly. But with percentages, we can compare different quantities simply by calculating what percentage each one is of a whole. This makes comparisons much more straightforward and intuitive, especially when dealing with different data sets or categories. So, in essence, percentages allow us to compare things more easily by converting raw numbers into a common scale, percentages, rather than dealing with different ratios or units. This concept ties into our overall theme of understanding data more clearly and making meaningful comparisons. Now, let's move on to an important concept when working with percentages. Sometimes, the total of the quantities we're dealing with isn't exactly 100. In other words, the denominator isn't 100. When this happens, we need to do a little adjustment to find the percentage accurately. Specifically, we need to make the denominator equal to 100. This way, the percentage we calculate will be meaningful and comparable. So the key takeaway here is that if your total isn't 100, you should scale your numbers so that the denominator becomes 100. This ensures that your percentages truly reflect the proportions of the parts relative to the whole, even when the original total isn't 100. Now, let's talk about converting fractions to percentages. Fractions often have different denominators, which can make understanding their value a bit tricky. To turn a fraction into a percentage, we need to multiply the fraction by 100%. Essentially, this process helps us express the fraction as a part of 100, making it easier to compare and interpret. Remember, multiplying by 100% shifts the focus from the fraction's numerator and denominator to a familiar percentage value. This step is crucial in many real-world applications, like analyzing data or understanding proportions. So, mastering this conversion will definitely enhance your ability to interpret various numerical information accurately. Now, let's talk about converting decimals to percentages. To do this, the first step is to think of the decimal as a fraction. Once you have that fraction, the next move is to multiply it by 100%. This process essentially shifts the decimal point 2 places to the right, giving you the percentage equivalent. Remember, converting decimals to percentages is a key skill because it helps us interpret data more easily and communicate it more effectively. It ties back to our overall theme of understanding and working with different ways of representing numbers. So, mastering this conversion makes it simpler to analyze and compare information across various contexts. Let's talk about how parts always add to give a whole. When we know one part of a whole, we can actually figure out the other part. That's because all the parts together make up the entire thing, or what we call 100%. So, if you know one piece, you can find the missing piece by thinking about the whole as 100%. This concept helps us understand how parts work together to make a complete picture, which is really important in understanding how things fit and add up in math and real life. Now, let's have some fun with estimation. As you can see here, by using percentages, we can actually estimate parts of an area quite easily. For example, in this picture, each half of the pizza is 50%. So, if I wanted to estimate how much of the pizza is eaten or remaining, I could simply look at the percentages. It's a practical way to make quick calculations without needing exact measurements. This approach ties into our overall theme of understanding parts of a whole using simple, intuitive methods. Remember, percentages are a powerful tool to help us break down and analyze areas or quantities in a straightforward way. Now, let's talk about how we interpret percentages in real life. When we see a percentage, it's not just a number. It represents a part of a whole. For example, if I say that Seema is spending 20% of her income, what does that really mean? It means that for every 100 rupees she earns, she is spending 20 rupees. So, in simple terms, percentages help us understand proportional relationships. They allow us to see how much of something is involved relative to the total. This understanding is crucial because it helps us make better financial decisions and understand data more clearly in everyday life. Remember, interpreting percentages correctly is key to managing money wisely and analyzing information effectively. Let's look at how to convert percentages into actual numbers. For example, suppose 20% of students in a class of 45 students received a distinction. The question is, how many students actually got the distinction? To solve this, we take the percentage, 20%, and convert it into a decimal by dividing by 100. So, 20 divided by 100 equals 0.2. Then we multiply this decimal by the total number of students, which is 45. That gives us 0.2 times 45, which equals 9. So in this case, 9 students out of the 45 received a distinction. This example highlights the key idea. To find the actual number from a percentage, we multiply the percentage as a decimal by the total number. It's a simple but powerful way to connect percentages to real-world numbers, which is essential in understanding data and making informed decisions. Now, let's talk about ratios to percentages. This conversion is really useful when we want to ensure accuracy, especially in situations like mixing different elements or calculating test scores. Often, we're given parts of a whole in the form of ratios, and understanding how to convert these into percentages makes comparisons much more intuitive. Remember, ratios and percentages are just two ways of expressing the same relationship. It's all about how we choose to view the data. By mastering this conversion, we can better analyze and interpret various types of information, which ties back to our overall goal of making data more understandable and actionable. Now, let's talk about how we can determine the increase or decrease as a percentage. Sometimes, in real-life situations, we need to find out how much something has grown or shrunk relative to its original amount. For example, we might want to know how much the population has increased over a certain period, or how sales have decreased after a marketing campaign. The key point here is that expressing these changes as percentages helps us understand the magnitude of the change in a clear and comparable way. It's a useful tool for making sense of trends and making informed decisions. Remember, the core idea is to compare the difference between the two quantities to the original amount, then convert that into a percentage. This way, we can communicate these changes more effectively and see the bigger picture. So, whether it's an increase or a decrease, calculating the percentage change is a fundamental skill that ties back to our overall goal of understanding data and making smarter business or personal decisions. Let's talk about cost price and selling price. The cost price, or CP, is simply the amount you pay when you buy a product. It's the foundational cost that determines your expenses. On the other hand, the selling price, or SB, is what you set when you're ready to sell that product to your customers. These two prices are really important because they help us figure out whether our sales are profitable or not. If the selling price is higher than the cost price, then we're making a profit. But if it's lower, then we're at a loss. Understanding these concepts is key to managing a successful business. They connect directly to the overall theme of profitability and strategic pricing. So, always keep in mind how your selling price compares to your cost price. That's the core of making smart business decisions. Let's talk about profit or loss percentage. This is a useful way to understand how well a business is doing, and it's actually pretty straightforward. Essentially, we convert the profit or loss into a percentage, which helps us compare different transactions more easily. Now, a key point to remember is that this percentage is always calculated based on the cost price. So, regardless of selling price, we're looking at how much profit or loss we've made relative to what it cost us initially. This concept ties into our overall theme of financial analysis, as it provides a clear, standardized way to measure performance across various transactions. It's a simple yet powerful tool to gauge efficiency and profitability in any business. When we borrow some money from the bank, we have to pay a certain amount called interest. The original amount of money we borrow is known as the principal. The interest is basically the cost of using that money for a period of time. At the end of the year, we repay the bank not just the principal, but also the interest. This total amount we pay back is called the amount. The key formula to remember here is that the amount equals the principal plus the interest. This concept of simple interest helps us understand how borrowing costs work in a straightforward way, connecting directly to the overall theme of understanding financial calculations and managing loans effectively. Let's take a closer look at the variables involved in calculating simple interest. First, SI stands for simple interest itself, which is the amount earned or paid on a principal over a period of time. The next variable is P, which represents the principal, the original sum of money invested or borrowed. Then, we have R, the rate of interest, usually expressed as a percentage, indicating how much interest accrues per period. Finally, T stands for the time period, which is the duration for which the interest is calculated. Understanding how these variables interact is key to mastering how simple interest works and how to calculate it accurately. Now, let's look at how to calculate simple interest over a 3-year period. Imagine we have a principal amount of 200 rupees and the interest rate is 10% per year. To find the interest for 1 year, we would multiply the principal by the rate and then divide by 100. But since we're looking at 3 years, we multiply by 3. So the calculation becomes 200 times 10 times 3 divided by 100, which gives us 60 rupees. That's the total interest earned over 3 years. Finally, to find the total amount after 3 years, we simply add the interest to the principal. That's 200 rupees plus 60 rupees, which equals 260 rupees. This example highlights the simplicity of calculating interest, just a matter of multiplying and dividing, and then adding to the original amount. It's a fundamental concept that ties into understanding how investments grow over time.